Okay, welcome back to our next topic. Now, today we will learn progressions. Okay, we have three types of progression. We have the arithmetic progression, geometric progression, and the harmonic progression. We will start with the arithmetic progression. So I have here an example of the arithmetic progression. So here is my example. 2, 4, 6, 8. So this is an arithmetic progression. No? Another example is -5, we have 0, 5, 10. So that is also an arithmetic progression. Now you can see here that the arithmetic progression is characterized by its common difference. Okay, so in example number 1, you will see here that they have a common difference of 2. So we will label our common difference as D. And for the next example, the common difference here is equal to 5. Let's have another example here. Let's say I have here 100, and then I have here 93, and I have here 86, and so on. So in this example, we have a common difference of -7. So meaning to say, the common difference can be positive or negative. So positive if the numbers are increasing, negative if the numbers are decreasing. Okay, let me erase this part first. Okay, so take note, the arithmetic progression is characterized by its common difference. Now, say for example, now if my first term, so I will label this as my first term, A1, is A, okay, and my common difference is D, what would be the next term? Okay, that is the sum of your first term plus the common difference. So this will become A1 plus D. Okay, now for my next term, again, I will add this by D. So this will become A1 plus 2D. So another term, let's say, this is A1 by the way, A1. So another D, another term with a common difference of D. This will become A1 plus 3D. So that's how you write the arithmetic progression in terms of A1 and D. So we can label this as your first term, second term, A2, third term, A3, fourth term, A4, and so on. Let's say we want to solve for AN until AN. So AN is the any term of the arithmetic progression. Now, let's go back to A2 here. So A2 can be written as A1 plus the common difference, right? While A3 can be written as A1 plus the 2 times the common difference. For the fourth term, we have A1 plus 3 times common difference. Take note of the subscript here. So this corresponds also to the subscript, or to the coefficient of your common difference, D. So if this is 2, the coefficient here is 1. If this is 3, okay, the coefficient here is 2. If this is 4, the coefficient is 3. What if, now we will solve for the nth term. So AN here is the nth term. Nth term means any term in your arithmetic progression. So we can label this as any term of AP. So AP is your arithmetic progression. Okay. So for any term, take note, if this is n, if this is AN, the AN can be represented by a1 plus. What? Take note of the numbers here. Okay, what happens to the number? If this is an, this will become an minus 1. That's the coefficient of your common difference. Now, this is now your how you take the nth term of the arithmetic progression. So just try to um, remember this one. So in this topic, I don't want you to memorize any formula. Okay, just try to familiarize this one. Later on, now it will be easier for us to use um, to solve the problems without using any formula. Okay, just remember this one. Okay, because we will be using that later on. Okay, now shall we start our first topic, our first problem? Okay, let's have an example here. So I will erase this first. I will erase this part. Okay, let's make it clean. Okay. So we can have our example here. Let's say I have here the numbers. Uh, let's say I have the numbers 8, then there's a blank here. Then I have the number here 12, then 14, then let's say 16. Okay, that's it. So and so on. Okay, so here a1 is 8 is your first term. This blank is your second term. Let's label this as a3. That's your third term. A4 and a5. So let's say I have 20 terms here. Okay, we don't know that term, the 20th term. So we can easily solve for the 20th term if we know the common difference, right? So to solve this problem, let's say the problem will ask you what is the 20th term. So the 20th term can be written as a20, that's the 20th term. That is just equal to a1 plus 19 times d. Okay, take note. Okay, the number here is one less than the term, the number of terms. Okay, so 19 times d. So we have a1, which is equivalent to 8 plus 19. But do we have the common difference? Yes. By just looking at these successive numbers, you can tell that the common difference here is equal to 2. So this will now be 2. Okay. So therefore, now you can solve for the 20th term as 8 plus 19 times 2. We will use our calculator here. So we have 8 plus 19 multiplied by 2. That's 46. And 46 is the 20th term of this arithmetic series. Okay? This is just an introduction. So take note, we will not be using any formula later on. So I will teach you how to analyze this problem without using formulas. Okay, I will erase this part first. Okay, and then let me give you these three problems. These three terms: 8, a blank, and a 12. Assuming we don't know, okay, we don't know the number here. We still don't know the number. Okay, I erased that one. So, okay, assuming we don't know the numbers, the number between 8 and 12. Now, how are we going to do that? So we call this number as your arithmetic mean. So arithmetic. So the arithmetic mean is the mean value of the two numbers. Meaning when we say mean value, when you add the two numbers and divide it by 2, that's the number. That is your arithmetic mean. So meaning to say your arithmetic mean can be calculated if you will add the two numbers, okay, 8 plus 12, and divide it by 2, your arithmetic mean is equal to 10. So that is the arithmetic mean. So I can show you later on how to derive the arithmetic mean. Now it is really simple how to derive this one. So I'll just show it you now. To derive this one, you need to solve for d. So let's say the arithmetic mean here is denoted as x. So meaning to say, if 12 is subtracted by the number x, the result would be x subtracted by 8 because they have a common difference, right? Now, if you will manipulate things, this will become 20, this will become 2x, and then x is equal to 10, and this is your arithmetic mean. So take note of that because later on, I will give you problems regarding arithmetic and geometric mean. All right, so let's move on. Okay, let's start with this problem. Okay, according to the problem, the 40th term of the arithmetic progression 4, 8, 12, 16 is, so we don't know. Okay, but we already know your A1, okay, and your common difference. So the common difference here by inspection, that is equal to 4. That's the common difference. Take note. So before you check if this is really an arithmetic series or arithmetic progression, you have to look for the numbers if they have the common difference. Like for example, 8 and 12, the common difference is 4. 16 and 12, the common difference is 4. So meaning to say, this progression or this series is an arithmetic series or arithmetic progression. Then that's it. So we will be using two methods here. The first method is using the any term of the arithmetic progression. So we have discussed this a while ago. So A40 can be A1 plus 39 times D. Take note, this is always 1 less than 40. Okay. Since A1 is given, which is 4 plus 39 times the number here, okay, which is 4. Now you can solve for the 40th term. So 40th term can be equal to what? So let's just use your calculator. 4 plus 39 times 4. Okay, so that is 160. So 160 is the 40th term. Okay, that is using your arithmetic progression. Using your the formula that we have a while ago. So let me introduce you this new solution, alternative solution. So I will be solving this problem using linear regression. So using linear regression, take note, your arithmetic progression, now when plotted, now it will form a line. Take note of that. So this is actually the value of the line. So when plotted. So take note, arithmetic progression is a linear regression. So we need a linear equation, So we need to use linear regression to make the problem more easier. Okay, using your calculator is equipped with linear regression. So in your calculator, go to mode. This is mode, okay, and then press stat because linear regression can be found in your stat. So press 3, and then since we are using a single variable, okay, a single variable. No, not a single variable. We are using a linear equation. So when we say linear equation, that is denoted by a plus bx. This one, a plus bx. This is a linear equation. A plus bx is linear equation. That is your linear regression actually. So press 2, and these are the values. So what are these values of x? The values of x are the terms. Like for example, Your 4 here is the first term. Okay, I will change the color. 8 here is the second term, third term, fourth term, and we are looking for the 40th term, which is unknown. Okay, for 40th term. So we will be using your calculator. The best thing to do here, so since this is a linear regression, we only need two values. Okay, that's the minimum number. We need a minimum of two values. X here is your value, your term. Okay, so X is your term, and Y here is the value of that term. So what are we going to do now is to input in your calculator. So 1, 2, this is your first term, and this is your second term. Your first term, the value is 4, so the value should be in Y. And the second term will be 8. So do that in your calculator. So you have 1, press equal sign, 2, press equal sign. So as I have said a while ago, we only need two values. Okay, that's the minimum. So the first term is equivalent to 4. Okay, the second term is equivalent to 8. Now we have a line. So we have supplied the data in our stat. So press all clear, and then go to shift. Okay, and go to stat. Okay, take note. We will be dealing with regression because we are looking for the value of this 40th term. So I will solve the 40th term. So this is 40. Okay, this is the 40th term, and we don't know the value. I will just label that as as y hat. We read this as y hat. So y hat. So we will be looking for 40 y hat. So 40 y hat is your 40th term, so A40. So that will be in your calculator. So again, all clear. Shift, go to stat, and then press regression or 5. So since we are looking for the value, which is y hat, okay, so we need to press 5, that's for y hat, and then press the arrow key so you can insert the number 40 before y hat. Okay. So this is now your 40th term. So press enter and you have your 160 as your 40th term. So therefore A40 equals 160. That's your 40th term. So that is easy, right? So we will do that again later on. So if I have here, now if the 10th term of the arithmetic progression of the arithmetic series, take note, progression can also be called series. Okay? Don't confuse with progression series. Okay, if the 10th term of the arithmetic series is 30, so 10th term is given, so we can say A10 is 33, and the 15th term, that's A15, equals to 53. What is the 20th term? So we will solve this in two ways. First method is using the manual approach. Okay, so A10 can be written as A1 plus 9D. That's A10, right? So this is equal to 33. Okay, and A15 can be written as A1 plus 14D, which is equal to 53. So our goal is to solve for the 20th term. So the 20th term is just A1 plus 19 times D. Since we don't have A1 and D, we need to solve A1 and D first, before we plug the value to A20. So using our calculator, this is actually a two equations to unknown. Okay. So since we are here, go back to our calculator, we are in stat mode. We need to go back to computation mode. And this time, I will change the mode to equation because we are going to solve for the value of A1 in D. Okay. So we have two equations and two variables, then we will use this one. Okay, so input the coefficients. So we have 1, we have 9, and we have 33. Okay, we also have 1, we have 14, and 53. So 53. Press equal sign. Now that's the value of your x. X is your a1, so that is your a1. So a1 is equals to negative 3. Press equal sign again. That's your y. No? So y is your common difference, which is 4. So meaning the series started at negative 3. So if we plug in negative 3 to a1 and 4 to d, so we have negative 3 plus 19 times 4. So this is now your 20th term. So using your calculator, so press mode 1. So we have negative 3 plus 19 times 4. That is 73. So 73 is the 20th term. This is using mathematics. Okay, you don't have to memorize any formula. So I did not memorize any formulas here. I derived the formula before using it. Okay, take note. I will be solving this using two methods. So the first method is the commonly used method. The next method is using linear regression. So using linear regression, we go put your calculator to mode. Okay, I will write it here. Mode, then stat. Okay, then select stat, then select a plus bx. Okay, that's the linear equation. And then input the values. That's right. Mode, stat, that's 3. And then we will select a plus bx, and we will input two values. Now, in your table, take note, in your table, this is your x and y. This is given. So according to the problem, the 10th term, so that is your x, the value is 33. The 15th term, the value is 53. And we are going to solve for the 20th term. That is 20y. Okay, so we need to find 20y using your calculator. So we will input the terms, that is 10th term and 15th term. So again, so in linear regression, we only need two values. So 10th term is 33, the 15th term is 53. Okay, after entering the values, press all clear, then shift, go to stat, and go to regression. Okay, and then look for y hat. So this is y hat. Okay, and then put your cursor before the y hat and input 20. So that's 20 y hat. So 20 y hat is your A20. So this is your A20 or the 20th term. So press equal sign. There you go. So you have 73. Okay. So you don't need to memorize any formulas. Okay. So in this correlation subject, no, we will some of the formulas no need to memorize, but most of them no we will not memorize it. So let's use it, and then when you are using it, no, always no, that's the best way to recall formulas. Use it. Okay. Next problem. Okay, here is another problem. So we have here the three terms no, of the arithmetic progression, but these terms are in terms with variable. So the first term is x plus 2, the second term is 3x minus 4, and 2x plus 7 is the third term. So take note of the relationship. Okay? Take note of the relationship. So if you have three terms, this term and this term, okay, the middle term is your arithmetic mean, right? So we have discussed that a while ago. Okay, this is your arithmetic mean. So can you still recall now how to solve for the arithmetic mean? Yes. Okay, arithmetic mean is just simple. You have to add the two numbers and divide it by 2. Okay, let's try that. 3x plus 4, that's your arithmetic mean. That is equal to, if you are going to add the two terms, the first term and the third term, okay, and divide that by 2. So this is the first term, this is the third term, and if you divide it by 2, it will be equal to your second term. So simplifying it further, you will have, let's simplify this one, x and 2x will become 3x, 2 and 7 will become 9. So this will become 3x plus 9 all over 2. So we have 3x minus 4. So just manipulate the value of x. Take note, avoid using shift solve, okay? Avoid using shift solve. So it's better to manipulate it. So cross multiplying 2 to the other side of the equation, this will become 6x minus 8. This will become 3x plus 9. So combining like terms, and I will put it here, we will combine like terms. So 6x minus 3x is 3x. Negative 8, now when transposed to the other side, it becomes positive, so this will become 17. So meaning to say x is equal to 17. Right? So that's it, because we are looking for the value of x. 17 divided by 3. Okay. That's 17 over 3. So where is it? So it's right here, 17 over 3. So this is your arithmetic mean. Okay. Now we go to your sum of your arithmetic progression. So a while ago, no, we have this series. We have this progression, A1, that's the first term. We have A1 plus D, that's the second term. We have A1 plus 2D, that's the third term, and so on. Now we can represent this any term as A1 plus, okay, take note, we will be representing this to any term. So n minus 1 times t. So this is now your an. So any term of the arithmetic progression. Now, if you are going to solve for the sum, okay, when we say sum, now we will be looking for the summation, okay, sum or summation. So this is summation of a1, okay, plus n minus 1 times d, okay, where n here, will start from 1 to any term. So any term. So I will just put any term here. Okay. So any term. So I will erase this part first. What is any term? Let's say, okay, erase. Let's say I want to solve now the 50 term. Okay, so I will put 1 to 50. But take note, no, I will not be using this. I will be using a different approach. Now without n minus 1. Okay? Now without n minus 1, now we can rewrite this. As summation, okay, of a plus bx. Okay. Remember this? This is your linear regression, right? Where x now is equal to from 0 up to n minus 1. So take note, from 0 to n minus 1. So here, a here, so let me erase this part first. Let me erase this part, okay? Sorry for that. This is erase, delete, delete, Okay, that's it. Delete. Okay, let's go back to the summation. So summation no, of a plus bx, okay, where x is equals to 0 up to n minus 1. So we will be using this sigma notation. So we will label this as the sum of the sum of n terms. So this is Sn. Sn is the sum of n terms. What about a and b? So a here is your first term. Take note of that. This is your first term, and b here is your common difference. Take note of that. First term and the common difference, because we will be using this after to solve this problem. Okay, so let's try. Let's try to solve this problem using this method. Okay, so we will solving for the sum of the first 50 terms. So you can write that as from x equals 0, that's the first term, up to 49. Okay, and then your first term is 2, that's your a, so you can write that as 2 plus, take note of the common difference. The common difference now by inspection is 3, so you can write that as 3x. That's it. We did not memorize any formula, no, that in your arithmetic progression. So try to avoid memorizing your formulas, because later on, no, in your major subjects, there are lots of formulas to be memorized. So in algebra, no, let's try to eliminate some of them. Okay. So using your calculator, you can easily solve this sigma function. So mode, okay, I will put my calculator to computation mode, and then I will use sigma notation, sigma function. So summation, this is called summation of 2 plus 3x. Take note, 2 here is your first term, and 3 here is the common difference. Okay, and the value of x will start from 0 up to 49. So 0 to 49 is 50 terms. Okay, press equal sign, and you have your answer, 3,775. Where is it? So here. It's here. So that will be the sum of arithmetic progression. So any questions with the sum of arithmetic progression? No. So how about if we will use the formula? Can still recall the formula? No. So okay, I will erase this part. I will show you how to calculate this manually using the formula, okay, in your arithmetic series. Okay, so the sum of the nth terms, so I will write it here, sum of the nth terms of arithmetic progression is simply n all over 2. Multiply that by 2a1 plus n minus 1 multiplied by t. If you can still recall this one, I gave this to you, no, weeks ago. So n here is the number of terms. So n here is 50. So all over 2. Your a1 is 2 times 2, that will be 4. Okay, plus. Okay, n here is 50, so this will become 49 multiplied by the common difference, which is 3. So the result will be 3775. Let's try it in our calculator. Maybe the answer is not the same. Okay, so 50 over 2 is 25. So I can just write 25 multiplied by, okay, I will just use this one, 4 plus 49 times 3. Okay, that's it. That's 3775. That is the sum of your arithmetic progression. Okay, can you still recall this one? All right. So there are lots of formulas not to be memorized. So please, no, try to avoid memorization, memorizing the formulas. Oh, why did I erase that one? Okay, now proceed to our next problem. Okay, how about this one? So let me read the problem first. The sum of the fourth and eighth terms of an arithmetic progression is 32. Take note. Now I will write this as the sum of the fourth term and the eighth term. Okay. By the way, eighth term, A8. So A8 now is equal to 32. Okay. And A10 and the sum of the 10th term. So you can write that as A10 and the 14th term is 68. Okay, that's how you write your equation. Then we will be solving what is the sum of the first 50 terms. So meaning to say, we are looking for S15. So we are looking for S. Oh, what is this S? So let me use this one. Okay. Oh, oh. Okay, I'll just write here S. Okay, this is S15. So we will be looking for S15. Okay, is that okay with you? Of course. Okay, let's try to solve for this. So how are we going to do this? First, now we are going to change now A4, A8, A10, and A14 in terms of A1 and D. So A4 is A1 plus 3D, right? Okay. And A8 is A1 plus 7D, which is equal to 32. And then A10 is A1 plus 9D, and A14 is A1 plus 13D, which is equal to 68. So simplifying it further, let's simplify the equation further. We will erase this part. We will combine like terms. So we will first combine like terms in our first equation. That will become 2A1 plus 7 and 3, that will become 10D is equal to 32. Same is true with the next equation, A1. 9 and 13, that's 22D is equal to 68. Now we have two equations and two unknowns. Okay, now we can use our calculator. So mode equation. So go to mode, go to equation. That's the best way of using your calculator. Just write down the equation and then use the calculator to solve for the unknowns. So plug in the coefficient. We have 2, we have 10, and 32. We also have 2, 22, and 68. Press equal sign. Okay, now we have the value of x. This is actually your a. So a1 is equal to 1, and then the value of d is equal to 3. So d is equal to 3. Now you have a1 and 3. Okay, so we can actually solve for the sum. Okay. Let me write the series here. Okay, the series is a1 is 1. Okay, that's the series. The second term will be what? D is 3, so meaning the second term is 4. The third term is plus 3, that's 7, and so on, until we reach the 10th term. So we will be solving the sum up to 15 terms. I mean, this is 15 terms because we are looking for S15. Okay. Now, since we already know, okay, A1 and D, now we can now use our summation formula, right? So mode 1 summation formula. Summation formula is summation of 1, that's your first term, plus 3, that's your common difference, and then put x. Okay. How many terms do we have? 14. So that is plus 0 to 15. That's 0 to, that is 0 to 14. That's your sum. That is the sum of the first 15 terms, so press equal sign. Then there you go, we have 330. Of course, you can do this using manual calculation, and that's not a problem. Okay, next we have geometric progression. So let's recall the basics of geometric progression. So if I have here 2, and then I have here 4, then 8, then 16, and so on. This is a geometric progression. So another one. So another, we have 10, we have 5, we have 5 halves, and we have 5 fourths, and so on. This is also a geometric progression. So both of these are geometric progression. So geometric progression is characterized by its common ratio. So they have a common ratio. What is this common ratio? So common ratio is denoted by R, that is equivalent to the next term over the previous term. So 2 over 4, which is equal to 8 over 4, which is equal to 16 over 8. So that's how you solve for the common ratio of the geometric progression. So meaning to say, the geometric progression can be a1, no, that's the first term, then a1 times r, that is the common ratio, times a1, that's the second term, a1 times r squared, that's the third term, a1 times r cubed, that's the fourth term. So let's label this as first term, second term, third term, and fourth term. Okay, fourth. Okay, let's label this as a1, a2, or you can just write a1, a2, a3, and a4. Okay, so how about the any term? Let's say I want to find out what is an. How are you going to do that? So it's simple. Okay, an is just equal to a1 times, take note, look at the value of the subscript here. So the subscript here is 2 because that is a second term, and the exponent of r is 1. If the subscript is 3, the exponent is 2. If this is 4, the exponent is 3. So meaning to say, if this is n, the exponent is n minus 1. So this is now your any term of your geometric progression. So take note of that, and we will be using that later on. Let's try this one. What is the ninth term of the progression? 4, 8, 16, and 32. So the ninth term is really simple. You can just say a9 equals to a1 multiplied by r, okay, raised to 8. So take note, the exponent of r is always 1 less than the subscript of a. So a1 is given, which is 4, and the common ratio is 8 over 4. So common ratio is 2, common ratio is 2, common ratio is 2. So that is 2 to the power of 8. That's how you solve for the ninth term. So you can say 4 multiplied by 2 to the power of 8. That is your ninth term. That would be 1024. Okay. Now, if we will be using our regression, okay, this is actually a regression. Geometric progression is a type of exponential regression. So exponential regression, since if you will plot these numbers, if you will plot these numbers, the graph will look like this one. So exponential regression. So you can go to mode. Okay, let's try it now. Go to mode. Start. This time now we will be using exponential regression. So exponential regression, you can use a times x raised to b. A times x raised to b. So that's 7. Go to mode. then stat and look for a okay, by the way, what did I choose? Mode stat. Okay, here now 6 a times b raised to x. You have to choose 6, not 7, 6. That is the exponential regression. So take note of the variables here, a and b. A here is actually your, this is your first term. First term, we will be using that later on. And b here is your common ratio. Okay, take note of the first term and your common ratio. Okay, now, since we are here now in the exponential regression, we now need to input at least two values. Let's say the first term and the second term. And aligned with the first term, we have 4 as the value, and the second term as 8. Okay, take note. Okay, that's 1 and 4, 2 and 8. Okay, all clear. See, and we will be looking for ninth term. So if this is our table, okay, x and y, I have here the first term, the second term, which is 4 and 8, and we will be solving for the ninth term. So that's 9y hat. So we need to solve for 9y hat. So go to shift, go to stat, look for regression, and look for y hat. Here is y hat, press 5. And before y hat, you have to insert 9. So that is 9y hat. So 9y hat is actually your A9, which is 10, 24. Okay, take note of that. This will make your life easier in mathematics. Okay, next problem. So I have here the fourth term of the geometric progression is 1 to 8. So I can say that the fourth term is equals to 1 to 8, and the eighth term is equal to 8. So what is the 12th term? So 12th term is unknown. So you can use a manual method, or you may use your calculator method. Okay, let's go to mode stat, and then press 6. That is your exponential regression. So mode stat. So how do we do this? This is your x and y, and the first term, the second term. Okay, what is the no, this is not the first term and second term. This is the fourth term and eighth term. So you will be writing here fourth term, fourth term, which is equal to 1 to 8, and the eighth term, which is equal to 8, and we will look for the value of 12y hat. So y hat if you are looking for the value of the 12th term. So x hat if you are looking for the number or the term. Okay, what is the number? What is the term? Okay, if you are what is the term that the value is equal to blah blah blah. So that is x hat. But in our case, now in our problem, we will need to solve for 12y hat. So enter the number 4 and 8 in your calculator. So corresponding to the terms, you have to input the values. Let's say 4 term is 1 to 8. 8 term is equal to 8. Okay, take note. You need only minimum of 2 values. You can enter 3 or more if you want. So go to mode, stat, and look for regression and y hat. And insert, before y hat, insert 12 because we are looking for the 12th term. Okay, so that's 0.5 or 1 half. So 0.5 is our 12th term, or that is 1 half. Okay, now we can do this using manual calculation. No? Like for example, if A4 is given, the fourth term is given here. A4, let's write A4. That is equivalent to 128, and the eighth term, that's A8, is equal to the value 8. Now let's try to solve for, let's convert this to a1 and r. So a4 is a1 times r cubed, right? And that is equivalent to 128. Okay, that's how you represent the value. So a2 or a8 now can be represented by r raised to 7, which is equal to 8. So we are looking for a12. That's the 12th term. Okay. The best solution here is to divide the equation. So let's divide a1 and let's divide this equation by this equation. So the result will be a1 will be cancelled out. The result will be r raised to negative 4. And then 128 divided by 8. So we will divide this one is equal to 16. Okay. That's it. So therefore, you can solve for the value of r, which is equal to, so if you are not sure, now you can just use the root. Okay. The negative 4 is, and we have 16. So r is equal to 1/2. Okay. R is equal to 1/2. Okay. So r is 1/2, and then we will solve for the value of a. So to solve for the value of a, we can just use this equation or the other equation. Let's solve using this equation. So since r is equal to 1/2, a1, well, a1 is equal to 8 divided by 1/2 raised to 7. So that's your a1. So a1, okay, a1 divided by, a1 is equals to 8 divided by 1/2 raised to 7. So 1/2 raised to 7, 1/2. Okay. Anyway, what? Again, 8. Okay. Divided by, we have here 8 divided by, so I will just put 1 raised to 7 first, and then 1/2. So it's really hard. It's still the same. Okay? Anyway, they have the same values. That's 10. That's 104. So a1 is 104. 120. 1024, not 104. So 1024 is the value of a1. Now to solve for a12, now we can just use a1 times r raised to 11. So since a1 is 1024 and r is 1/2, that will be raised to 11. So the value of a12 is equal to 1/2. So try that in your calculator. So this is r. I will be using my calculator. 1024. Multiply that by, okay, multiply that by 0.5. I will just use 0.5 raised to 11. There you go. The answer is 1/2. Okay. Now we proceed to the next problem. Okay, what is the sum of the first 10 terms of the geometric progression? So let's go back to the sum of the geometric progression. So a while ago, any term. So any term of the geometric progression can be represented by a1 times r raised to n minus 1. Okay. Now, if I'm going to use sigma notation to represent this one, so I will label this a1 as a, I will label my r as b, and I will label my x, my n minus 1 as x. Okay, this is any term, okay, of the geometric progression. So the sum, that is why we used, that is why in our stat we use exponential regression. Okay, now for the summation, for the sum, I will erase this first and insert the sum here. So the sum of the geometric progression, okay, is n. So Sn is equivalent to, using sigma notation, is equivalent to A, that's my first term, B, that's my common ratio, and X. X here starts from 0 up to n minus 1. Remember, X is n minus 1. Okay, take note of that. So A here, now let's label this as my first term, and B here will be the common ratio. Alright, now let's do this. So sum, therefore, okay, sum from 0 to 9. Okay, your first term is 4. Okay, and your common ratio is 12 divided by 4. That's 3 raised to x. Okay, 4 times 3 raised to x. So I use that notation. So let's go to shift summation. We have 4 times 3 raised to x, where x starts from 0 up to 9, since we have 10 terms only. So we have summation, which is equivalent to 118096. So that is the sum of the geometric series. Okay, can you still recall how did I do this? Of course, this is very important. Recalling the techniques that I use here is really important. Okay, let's proceed to the next problem. This time we will be using, of course, our calculator. We have sum of geometric progression. So let me read the problem. The sum of the terms in geometric progression is 1 to 1820. So we don't know the terms. Okay, according to the problem, the sum of the terms is 820. We don't know the terms. Okay, how many terms are there? So we are looking for n. If the first term, so given the first term is 5, the second term is 15, and the third term is 45. Is 45. Here, not given, it is already given. First term and second term and third term. So for the sum, now using the sigma notation, is really simple. Since we don't know the sum, we don't know n, we can just use 0 up to I don't know. Okay, question mark. Okay, we will be using calc function here, or we will try to trial the choices here. Summation of the first term. Okay, this is the first term, 5 times the common ratio. Common ratio is just 15 divided by 5, or 45 divided by 15. That's 3, right? Raised to the value of x. The result should be 1820. Okay. Go back to your calculator. I will edit this one. So this is 5 times 3 raised to x. Okay, now we go to variable here. I will just use a variable here. Let's just use the variable, let's use the variable a, okay? And I will use the calc function. If I'm going to click calc function, okay, calc function, I will input 7. Let's try 7. By the way, no, this is wrong. Okay, this is wrong. Okay. Instead, now of using a, just use the number 7. So just type 7. The result should be 128, 1820. So this is wrong. 7 is wrong. So try 8. Try B. It is also wrong. Let's try C. That's 5. That is correct. So 5 here is correct using our calculator method. So what is important here is that you are going to what do you call this? You have this equation for sum. You have this equation for the sum, and what you will do here is to trial the values, the limit of your summation. Okay, so that's the number of terms. Take note, 5 here is not the correct answer. Okay, according to the problem, so from 0, according to the problem, now if I will put 5 here, okay, take note of that. So if I will put 5 here, okay, the answer is 1820. But take note, 5 is not the correct answer. Because the number of terms is from 0 up to 5. So the number of terms is actually 6. 0 to 5 is 6. But it so happened that 5 is 820, but you have to look that the number of terms will be 0 up to 5. That's 6. Okay. Now we go to our next problem. Oh, that's it for the harmonic progression. Let's discuss what is harmonic progression. So harmonic progression is something like this: 1/2, 1/3, 1/4, 1/5, 1/6. Harmonic progression. So if you will try to look at the denominator, they have a common difference, right? So what are the difference in your denominator? Okay, 1. So actually, the harmonic progression is just the reciprocal of your arithmetic progression. So the terms here, the terms in your denominator are your arithmetic series. Okay, but this will be, as a whole, this is your harmonic progression. Okay, so the denominators are your AP. So in this problem, we will be solving this using arithmetic progression. Okay, using arithmetic progression. So meaning to say, if you will try to look for the next term, let's say, what is the next term? What is the next term? So the next term of the harmonic progression is just the reciprocal of your arithmetic progression. Take note of that. Can you still recall the any term of the arithmetic progression? Yes, this is just a1 plus n minus 1 times t. So the reciprocal of that is the term in your harmonic progression. Okay? So meaning to say the sum will also be the reciprocal. Okay? The sum of the harmonic progression is just the reciprocal of the sum of your arithmetic progression, sum of AP. That's not the reciprocal. This is wrong. That's the wrong representation. This is the reciprocal of summation of a plus bx, or x is from 0 to n minus 1. This is how you denote the sum of the arithmetic progression. Take note, this is arithmetic progression. This is the sum of your harmonic progression. Let's do that later on. Let's solve this one. These are the 3 harmonic sequence. I will write the harmonic sequence. This is the harmonic progression 2, okay, 6 over 7, and 6 over 11. Let me read the problem. The first 3 terms of the harmonic sequence is 2, 6 over 7, and 6 over 11. The 5th term is, so as I have said a while ago, we are going to analyze this using arithmetic progression. And take note, the terms in the arithmetic progression is just the reciprocal of your harmonic progression. So meaning to say the first term will be 1/2, the second term will be 7 over 6, and the third term will be 11 over 6. Okay, this is the terms in arithmetic progression. So this is A1, this is A2, and this is A3, and we will look for A5. Okay, to look for A5 using arithmetic progression, this is just A1 plus 4D. Okay, so we have A1, we know A1, which is 1/2, okay, but we don't know D. So we need to solve for D. So how are we going to solve for D? Of course, we need to subtract. No, we need to subtract 1/2 from 7 over 6. So D can be calculated as 7 over 6 minus 1/2. Okay. So how are we going to do that? This is 1/2 can be uh, represented by 3 over 6. 1/2 can be represented by 3. What is 3 over 6? Okay, that will be 4 over 6 or 2 over 3. That is your D. So we will put 2/3 here, and then we will compute for a 5 because that is very important. So we have 1/2. I will just use 0.5 plus 4 times 2 divided by 3. Okay, this is 19 over 6. So this is 19 over 6 in arithmetic progression. But if we will transpose this, okay, 19 over 6 in harmonic progression, that will be 6 over 19, okay, in arithmetic progression. So take note the reciprocal of the terms, no, of the arithmetic and your harmonic progression. 16 over 9, 6 over 9 is the right answer. Let's proceed with the next one. So here, determine the fourth and eighth term of the harmonic progression. So take note, HP is given 6, 4, and 3. Take note, we will analyze this using the arithmetic progression. So this will become 1 over 6, 1 over 4, and 1 over 3. We will determine the fourth and eighth term. Fourth and eighth term. So this is easier if we will do calculator technique. We will use the calculator technique. Okay, in your calculator, since we will be using the arithmetic progression, so we have to go to mode stat and then select linear regression and input the numbers. So first term, second term. You may input third term if you want, but the minimum is just 2 numbers. The first term is 1 over 6. Take note, we are going to input the terms in arithmetic progression. The second term is 1 over 4, and the third term is 1 over 3. Okay, so mode. Okay, so I will create a table here. So this is X, and this is Y. I will use 1 over 6 and 1/4 in my table. So we will be looking for the fourth term, that is 4y hat, and 8y hat. The fourth term and the eighth term. Okay, so if I'm going to say mode stat, then regression, y hat, I will write 4. Then I will use colon notation. So is it possible if I will use colon notation? It's not possible, so we'll just use 4y hat first. We'll just solve for y hat. Okay, this is in decimal point. You can convert this to fraction by clicking this button. That's 5 over 12. Take note, 5 over 12 is the term in arithmetic progression. Okay. And now, press left arrow. Change this to 8 for the 8th term. So 0.75 is 3/4. Okay, 3/4. Okay. According to the problem, okay, let me insert, because I just made this problem. So there is no right answer here. Assuming this is the right answer. Okay, this is the right answer. So I will create the right answer. So the fourth term is 12 over 5. Because this is harmonic progression. 4 over 3. Okay, take note, no? So 5 over 12 here. 5 over 12 here, and This is 5 over 12. This is in arithmetic progression. Take note, we are dealing with arithmetic progression. So in order to make this a geometric progression, you are going to reciprocate it. So this will become 12 over 5. Okay, that's the fourth term. And the eighth term will be 4 over 3. So is that okay with you guys? Okay, that will be your final answer. Okay, so this is a simple problem. Okay, let's try another one. Okay, by the way, now the answer here is this one, because this is the terms you get when you use arithmetic progression, right? So you don't, this is wrong. Sometimes no, it is given in the choices, uh, and if you are dealing with this, no, always no, take the reciprocal of your arithmetic terms. Let's try. Compute the 16th term of HP. 16th term of HP and the 6th term. We will compute the 16th term of HP given the progression, the 6th term and the 11th term. 6th term is equal to 10. 11th term is equal to 18, okay, respectively. So meaning to say, when you convert that to AP, this is 1 over 10 and 1 over 18, right? 1 over 10 and 1 over 18, respectively. That is the 6th term and the 11th term. So, using the table, you can write this as 6 and 11. This is 10 and 18. So here, we need to solve for 16 y hat. That's the 16. Take note, 16 y hat here is still in arithmetic progression. So go to the table, mode, stat, arithmetic, then input na 6. That's the 6th to 11th term. So align with the 6th term, the value is 10 and 18. Okay. Now press shift, stop, reg, y hat, and look for 16 y hat. By the way, no, I have entered the wrong value. So instead of 10, this is 1 over 10 and 1 over 8. So let's redo our mode, stat mode 3, 2. Let's redo our table. So we have the 6th term and 11th term. Okay, that's 1 over 10 and 8. So be careful when entering your data. So it might confuse you. Actually, harmonic progression is actually very confusing because you are thinking of solving the arithmetic progression, but in fact, you are dealing with harmonic progression. So all clear. After you input some data there, reg, then choose y hat and enter 16. So this is 0.0011. Okay, 0.00111. If converted to a fraction, that will be 1 over 90. So 16 y hat is 1 over 90. I'll just write it here. 16 y hat is 1 over 90. So 1 over 90 is still in arithmetic progression. So for geometric progression, we are going to reciprocal that one. Take the reciprocal, the value will be 90. That is the 16th term of your HP. Alright. Now we will go to the next problem. So I hope you are still with me. This is actually a very long discussion because I have presented different problems here. Okay, where is my choices? I don't have a choices here, but still we will be solving the values here. Okay, the second and the fifth term, okay, of the harmonic progression is, so let's write it here. harmonic progression, second term, and fifth term. That is equivalent to 3 over 14 and 1 over 10. So if we will convert that to arithmetic progression, the second term will be 14 over 3, and then the fifth term will be 10. Okay, this is in arithmetic progression. And we will compute the sum, okay, of 6 and 7 term. So sum of 6 and 7 term. Take note, sum of 6 and 7 terms. So you can write that as 1 over, okay, a plus bx. Between, okay, x equals to 5, take note, 6 and 7 term. So that is 0, 1, 2, 3, 4, 5 is the 6th term, 6 is the 7th term. Okay. Alright, so we will be using this formula. But we need to first solve for the value of a in geometric progression. A here is the first term. It's given, that's 14 of, it's not given, actually this is the second term. So we need to find the first term. So we need to look for the first term, and then the common difference, okay, and then d, okay, first term and d. So where are we going to find that? Let's try the stat function. So in your stat function, mod stat to x and y, input the data in arithmetic progression. So I will be using arithmetic progression data. So this is my second term and fifth term. Second term is 14 over 3. Fifth term is 10. Okay. We will be looking for 1 y hat. Okay. And then the common difference. Let's try. Okay. Input 14 over input second term 2 and the fifth term. Okay. Next, we will input 14 over 3. Okay, that is in arithmetic progression, and we also have fifth term, which is 10. Okay, shift stat. Okay, this is your data. Okay. So if you press 5, that is your regression. So if you press 1, that is the value of your a. A here is your first term. So let's try 1. That's the value of a. Press enter. The value is 1.111. So that's your a. So I will write it here. A is equals to 1.111. So let's convert that to fraction instead of 111. Fraction. So that is 10 over 9. Okay. Now we go again to stat. And then go to reg, and then we will look for b. Take note, b here is the common difference. So type 2, type b, and then convert that to fraction. The common difference is 16 over 9. That's the common difference. Okay. Take note of using that method. Now we need to plug in this value to your summation equation. So I have no space there, then I will just write it here. So mode, no. Let's go to mode 1, normal mode, and then we will enter the summation. So this is 1 over so, a plus, not a, I will just use 10 over 9, 10 over 9, okay, plus b is 16 over 9 multiplied by x, okay, where x starts from 5. 5 there is actually the 6th term up to 6. 6 there is the 7th term. So we are actually summing the terms na 6 and 7. This is now the sum in harmonic progression. This is now in harmonic progression. Take note, this is now in harmonic progression. Okay. Alright, so this is equivalent to uh, 49 165. So this is 49 over 265. So that's the sum of the 6 and 7 terms. So try to review this one and check that using manual calculation. Okay? Okay, this will be the last problem. So find the sum of the first 10 terms. First 10 terms. This is the harmonic progression. So we need to convert this harmonic progression to its mm, equivalent in arithmetic progression. So for the harmonic progression, so I have here 1 half, we have 7 over 6 and 11 over 6. Okay. Now we need to find the sum of the first 10 terms. We all know that the sum Sn is just equal to summation of 1 over a plus bx, okay, where x starts from 0 up to n minus 1. So a is the first term in arithmetic progression. So this is now summation of n equals 0, x equals 0, I mean, up to 10 terms, that's 9, 1 over. So let's input the values here. 1 half is the first term in arithmetic progression plus a common difference. So we will need to solve the common difference. Let's just solve the common difference here. 11 over 6 minus 7 over 6. That's 4 over 6. Or 2/3. Okay, let's say 2/3 x. Then input that in your calculator. Okay? Input summation of 1 over a is 1 half, 1 okay, half plus, okay, 2/3, 2/3. Take note the sum here is now the sum of your harmonic progression with values from 0 up to 9, since we are going to solve for the sum of the first 10 terms. That's 5.12, so that is in letter A. Alright, okay, that's it for the progression topic. So next topic will be solving age problem, work problem, and so on. So worded problem. So I hope now you've learned a lot today. Okay, this is a very long lecture, so bear with it. What is important here is to study the techniques I used in solving the problem. Okay, see you on my next video.